Hi there, my name is Jennifer and I'm your host for the Manitoba Envirothon Wildlife Training Series. So today we're going to be working on the mark or capture method, and this is a method used to determine the population estimation of a particular species. It's also known as the Peterson method. And it's using a very simple calculation, which is N equals MC over R, or as my assistant Justin likes to do, think of MC Hammer. Alright, so what do these different letters represent? Well, N, that is your estimated population. Okay, M represents your marked species. C are your captured. And R represents recaptured. Now when you do the marker capture method, you always have to remember that you have to do it at least 3 times. You can't do it just once. Okay, so now what we're going to do is we're going to pretend that we're biologists and we're actually going to do a sample survey out in the field. So if I were going out, I would probably be doing, say, pretend I'm going for field mice. So I've set a trap and I've caught some mice. So my mice are going to be represented by these blue balls. So if I were actually out in the field, what I would do is I would capture the mouse, I would pick it up, and I would mark on the top of its head with some white out, and that would indicate that I have marked that species, because it's going to stay on the fur. When I recapture them, I can identify that species as the marked one. So we're going to pretend that my blue balls are the field mice, and when I mark them, what I'm going to do is I'm going to replace them with a yellow ball. So all of these yellow balls are going to represent the marked species. Okay? So I have captured 10 species on the first night, and I have marked them. So I have marked 10 species. So now that I know that I've marked 10 of them, I can put on the board here that every time I do M is always going to equal 10. No matter what I do, M is always 10, because I have 10 initial marked species. So after I mark my species, I'm going to release them back into the wild to go mix with the unmarked species in the bush. I'm going to reset my trap, and I'm going to check it the next day. Okay, so I have checked my trap the next day, and I've apparently caught a couple extras. It's okay if that one's not in. He got out, he ran away. So how many in total have I captured? I've captured 1, 2, 3, 4, 5, 6, 7 species, okay? So when I do this formula, we know that M is going to be 10, because those are the marked ones in total. C is captured, so 1, 2, 3, 4, 5, 6, 7, so I've captured 7. And how many have I recaptured? I simply count the yellow ones. I have 2. So we have 10 times 7 is 70, divided by 2, which is equal to 35, okay? So for our first estimation, we have an estimated population of 35. Obviously, I'm not just going to do this once. You need to do it multiple times in order to get an accurate average of your estimated population. So we release these guys back into the wild. Okay. Now, same thing again. We know that M is equal to 10. So how many have we captured this time? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. How many have we recaptured? 1, 2, 3, 4, 5. So 10 times 10 is 100, divided by 5. That's equal to, what is that, 20? I math. All right, so we got 20 for our next average estimation. Do it one more time. Straggler. Okay. So last time I'm going out and doing my survey, we know that we started with 10 initial marked. We have 1, 2, 3, 4, 5, 6, 7 captured in total. And how many do we have recaptured? 1, 2, 3, 4. So we know that 70 divided by 4, and because I have 0 math skills, The answer is 17.5. I would highly recommend that you use a calculator, even if it's something really, really easy, because if you're like me, it's really easy to make a mistake. So obviously, this isn't completed yet. What I have to do is I have to get the average of my estimated population. So I have to take 30 and go 30 plus 20 plus 17.5. And then I'm going to have to find the average, which means I'm going to divide that by 3. Because there's 3 estimations we've done. So we have an average population of 22.5. Okay? So that's how you do the marker capture. 23.5, 30, what? Did I make a boo-boo?
Your top number is 35.
Oh, and this is why you math. So the average population is focusing when you're doing your test question. And this is why you have teamwork, by the way. So your partner can go, hey Jen, you screwed up. And you go, ha, thanks Justin. And you find out that the average is actually 24.2. And then you get that answer right, because your buddy told you. So yeah, so the average is 24.2. So that's how you do the marker capture method. It's actually very, very easy. So practice it at school, practice it at home, and you'll get it right on the test. Hi, so now we're going to do our quadrat sampling method. This is another method to use to determine a population estimation. We use quadrat sampling for species that are slow-moving or stationary. So that's things like plants, slugs, insects, anything like that. So today, I'm going to show you using our room here and some of our examples of what we're going to do. It's a very simple formula. It's your average population density times your total area will give you your population size. So this room, we're going to pretend, is about 30 meters by 20 meters. So that information will be given to you, or maybe you'll have to go measure it out, but this information is right here, so you automatically already know what your total area is by simply going 30 meters squared, 30 meters times 20 meters is going to equal 600 meters squared. Make sure you show your work and make sure you have the proper, what is that word?
Units.
Units, thank you. Proper units, thanks Justin. So automatically we have our total area. Now when we want to find out our average population density, what I have is I have a field of puzzle pieces, so we'll pretend they're slugs. So I have slugs out in the field, and what I've done is I've randomly tossed out a hula hoop to represent our sample plot. Now our hula hoops are going to pretend that they're 1 meter by 1 meter, so it's 1 meter squared is our sample area. So you just simply toss it out because you don't want to have any bias. So that means that you don't want to go out and consciously think of where you want to place them. You want it to be completely random. So, excellent. So now what I'm going to go do is I'm going to go count how many I have in each of my plots. So, in our first plot, I've noticed that we have one species that's half in, half out. Now, if this species is 50% or more within the plot, then we're going to count it as in. So we have 1, 2, 3, 4. This one we have 1, 2, 3, and this one we have 2. So, go to our board here. Sometimes what I like to do is actually just draw it out, because it helps me to keep in mind what I have. So I have 3 in the back, 4 in the front, and 2 over here. So now all you have to do is find out the average population density of these sample plots. So it's simply 3 plus 2 plus 4 divided by your 3 different plots that you've done. Use a calculator no matter what, so you don't screw up, which is 3, because it's 9 divided by 3, which is 3. So now you just put your average population density and you multiply it by your total area. So you go 3 times 600 meters squared So it's 3 times 600, which is going to give you 1,800. So your answer for population size is 1,800. Now this is a very, very simple formula. It's very easy to do. So generally, if I were going to ask you this on a test, I might make it a little bit further complicated. Maybe you need to change the units or something like that. So just keep that in mind and practice, do different things, and yeah, there you go. All right, Envirothoners. So these are the 2 methods you need to practice, memorize, study hard, try it again and again until you master this technique. Because every year I test you. I test you hard on one of these 2, or maybe both. You'll never know. So study both, quadruped sampling and the Peterson method of the marker capture. Good luck.